A software project is made up of different parts or modules which have different and independent roles in the project, like the payments, the file manager, user interface, data access layer, and other modules which connect to third-party services. A module is made up of different blocks of code which are called methods. A method does a specific job in the module. Like the file manager involves in tasks like opening a file, reading a file, writing to a file, and closing the file. Here, each operation is done by a different method. In order to complete a bigger task, methods call other methods to include their functionality in themselves. Before we understand exception handling, we need to know what is a method stack. The execution always starts from main method in Java. Main method can call other methods from different classes, and those methods can further call other methods. If a main method calls other method, it sits on top of the main. And again, that method may call some other method, say method B. Then that method will sit on top of method A. This will form a kind of stack, which we call a method stack. Because unless the execution of current method is completed, the execution doesn't go back to the previous method. To understand the need of Java exception, let's listen to a short story. A person goes to a painter, gives him his car and a bucket of paint, and asks him to paint and return the car. The painter accepts the request, but he realizes that the amount of paint in the paint bucket is not sufficient to paint the entire car. But he goes ahead and paints it, and paints the remaining portion with whatever color was available with him. The person comes back, and after seeing his car, he complains the painter saying, "I had given you a paint bucket, but the car looks like being partially painted with a different color. Why is it so?" The painter says, "This has happened because the amount of paint you had given was not sufficient to paint the entire car. So I painted the remaining portion with the color that was available with me." Then the person complains, saying that if it was such a situation, then instead of taking your own decision, you should have informed me. The painter says, "Sorry for that. This was an exceptional case, because generally the painter doesn't face a situation where he runs short of paint. He didn't know what to do, so he took his own decision. There are two things that could have happened. Either he could have painted with the color he had, which he actually did, or he could have returned the partially painted car to the person, because the person was asking him to return the car. This was the only option he had given him. So imagine this case in a Java program. You have a code which calls a paint method, passes a car and a paint bucket as parameters, and expects to return the painted car. In this case, the method has to return what it is supposed to return at any cost. But then there are cases where things may go wrong, because the part of code which is not supposed to take decisions in this situation, like in this case, the painter worked upon somebody's private asset, like the car of that person. As I mentioned, ideally a method has a single and specific role. Like a painter's job is to paint the car and not take decisions. This is where a method has to raise his voice and say that this is an exceptional case and I am not the right person to take decision here. I am not an expert in this field. And this is where Java exception comes as a rescue. Even the word exception itself suggests the same. Our superhero tells the method to warn the caller that if the method faces such an exceptional situation where he runs out of paint, it will throw a bomb. And this bomb should be caught by the caller or any of the caller methods in the stack before it reaches the ground. Otherwise, it will boom. And the execution of program will abruptly terminate there. And the method says, "Okay," and warns the caller by adding a throw stack to its declaration. Let's say the name of the bomb is out of paint exception. And in the exceptional case, where the available paint is less than the required amount, the method throws the out of paint exception bomb using the throw keyword. Now comes the job of the caller method. Our superhero tells the caller method that As the paint method has already declared that it is prone to exception and it can throw the out of paint exception bomb anytime, so try to catch the bomb before it reaches the ground. So try and catch. The caller method surrounds the invocation of this method inside a try and catch block. Now let's execute the program. The caller calls the paint method. The paint method verifies the amount of paint and throws an out of paint exception if it is not sufficient. Because the caller method is ready to handle the situation, it catches the bomb and the execution comes to the catch block. In the Java world, everything is in the form of classes and objects. Java exception is also a class in Java. So in order to have an out of paint exception, we need to create a class which would be of the type exception. Let's check out the exception class hierarchy for that matter. On top of the hierarchy, we have the throwable interface, which is implemented by exception and error class. Exception class is what we are interested in right now. Exception class is further extended by runtime exception class. We will come to this when we will talk about checked and unchecked exceptions later in the video. An error also works like exception, but difference between an exception and an error is that a program is supposed to handle an exception but not an error. An error would be mostly thrown by Java interpreter when it faces some kind of difficulty in executing a piece of code. For example, when interpreter encounters a code for creating a new object and there is an insufficient space to allocate an object in the Java heap, it will throw out of memory error. Another example is stack overflow error, which is thrown when the stack is exhausted due to deep or infinite recursive methods. In these cases, it's better to avoid such code than to handle the situation. The difference between an exception and error is that exception is meant to be handled and error is something which should be avoided. It's not good for the program. Here I want to clarify that the code shown previously was just for your understanding and will not compile. To know the right code, stay tuned to this video. Moving ahead, so in order to have our own exception, that is the out of paint exception, we need this class to extend exception class. Its constructor requires a message as parameter. This message specifies the reason for throwing the exception. In case the reason for throwing this exception is delegating an exception that is being thrown on this method, then it can send that exception in the cause parameter. Cause is an optional parameter of type throwable. Then you can pass this parameter as well. So now when the paint method throws a new out of paint exception object, the caller method catches this exception and hence it will have the related information in the exception object. Exceptions are of two categories in Java, namely checked and unchecked exceptions. Subtypes of exception class are checked exceptions, and all the checked exceptions are monitored by the compiler. Compiler deliberately checks whether the method that is throwing a checked exception has actually declared it or not, and also the code invoking this method is handling the exception which is declared or not. The method invocation must be surrounded with try and catch. In these cases, the compiler will complain if the methods don't adhere to these rules. If a class is a subtype of runtime exception, then it is an unchecked exception. If the exception thrown by a method is unchecked, then the compiler ignores the above rules and allows the code to compile. In this case, the problem appears during the runtime, and it is the responsibility of the programmer to check the declaration of the callee method or the documentation if any, and handle that particular type of exception. If the exception goes uncaught during runtime, the program will abruptly terminate there. Let's talk about inbuilt and custom or user-defined exceptions. The exception class which we created previously, the out of paint exception, is a user-defined exception because we, the Java users, are defining it. Apart from the exception classes which are created by the programmer, there are inbuilt exceptions in Java. There are a lot of inbuilt exceptions which the Java library throws when it faces an exceptional situation. Consider, for example, the parseInt method of integer class. The job of this method is to parse a string value and evaluate and return an integer out of it. For instance, if we pass a string value of 1 to it, it returns the integer equivalent. Suppose we pass a string value something like Soumya, and it's kind of not possible for the parseInt method to evaluate this to an integer, in which case the parseInt method throws the number format exception in order to inform the caller that this string value is unparsable. Here, the number format exception is an unchecked exception and thus is ignored by the compiler. And if the exception goes uncaught by the caller method during runtime, the program will abruptly terminate there. Whenever you call a method from an external library, it is your duty to check the documentation of that method. As we check the parameters we need to pass in the method, similarly, it is important to check which exceptions the method is throwing.